Hello there, and thank you for clicking on this video. Wanted to address really quickly, does it matter where my zero is when you're solving a quadratic using the quadratic formula? Typically, this is when we would do this. So consider the equation x squared equals 3x plus 28, and suppose you have to solve this using the quadratic formula. Well, there are two ways that you can get it into the correct form. Option one is to subtract 3x and 28 from both sides. So you'll get x squared minus 3x minus 28 equals 0. And in that case, your a value is 1, your b value is -3, and your c value is -28. But somebody else might say, hey, it's easier for me to just subtract the x squared. And so option two would be to get the x squared over on the right. So you would have 0 equals -x squared plus 3x plus 28, or you can see you could just switch that around using the symmetric property of equality. And in that case, your a value is -1, b is +3, and c is +28. And you'll notice that the numbers for your a, b, and c are all opposites of each other because you've gotten them to the opposite side of the equation. Well, if you were to graph the one on the left, remember, if we solve it by graphing, you're looking for the x-intercepts, and you can see that the x-intercepts there are at -4 and +7. So we know the solution to that equation is -4 and +7 based on the x-intercepts. So what happens when we graph the one on the right? Well, we definitely have a different graph, and that's because we have different values of a, b, and c. However, if you look at where the x-intercepts are, you will see that the x-intercepts are in exactly the same position. So by moving the expression to one side versus the other, it will flip the graph over, but it doesn't change the x-intercepts. So when you are using the quadratic formula, it actually does not matter where you get your zero. As long as you're consistent, you get everything onto one side and you don't try to mix and match the two sides together. So I hope this illustrates for you with a graph why you can do the problem either way.